Hey guys, so today we're going to discuss how to name ionic compounds. So hopefully you remember that ionic compounds result from the transfer of electrons, okay? So it is an electrostatic interaction between a positive particle, whether it be an atom or a polyatomic ion, and a negative particle, okay? So we recognize these because they are a metal plus a nonmetal, or a metal plus a metalloid, or a metal plus a polyatomic ion. But it's important when we have ionic compounds, we always write the metal first. So we'll have the form metal plus nonmetal slash, we'll put Pi for polyatomic ion, okay, that you have memorized. Okay? So another thing about ionic compounds, the net charge is always 0. Okay? So we'll have some positive charges, we'll have some negative charges, but the sum of those charges will always be 0. You always have an overall neutral compound. Okay, so let's go ahead and jump right in. First, we want to talk about naming binary, okay, ionic compounds. So a binary compound is just a compound that consists of only 2 atoms, okay? So we have 2 rules here. The first rule is to name the metal. So let's write the rules out, then we'll kind of discuss what they mean more. And the second rule is name, and I'll abbreviate this, nonmetal with ending changed to IDE. Okay. So those are the 2 rules for naming binary ionic compounds. Let's go ahead and try some of these. So we can have K3N, Li, L or CaCl2. Okay, so we name the metal, potassium. Then we name the nonmetal with the ending changed to IDE. So it's not potassium nitrogen, it's potassium nitride. So I simply change the ending on that to IDE. And that's it. The name for this molecule is potassium nitride. So let's try another one. Name the metal, lithium. Okay. Name the nonmetal with the ending changed to IDE. F is fluorine. Fluorine with the ending changed to IDE is fluoride. Okay. And the last one is, we start off with name the metal, calcium. And then we have chlorine. Change the ending on chlorine to IDE, so chloride. So fairly simple, right? Name the metal, name the nonmetal, change the ending to IDE, and you're in good shape. So you'll find that all these rules on their own are very, very simple. They get a little tricky though when you have a big long list of compounds and you have to think, well, which one of these rules do I use in this situation? So what we're going to do is go through and look at each rule individually, and then we'll go back and mix them up and talk about it. So next, I want to name compounds with polyatomic ions. So the rule here is you just name what you see, okay? If you have a polyatomic ion in an ionic compound, just name what you see. Don't do anything fancy. So we have BaSO4, we have CaCO3, we have NH4, C2H3O2. Okay. So in your notes, these parentheses are written here to help you recognize the polyatomic ion. It is very typical to not use these, so you'll just have BaSO4, CaCO3, NH4, C2H3O2. Okay. So you shouldn't write those parentheses in unless there's a need for it, and we'll discuss later why there could be a need. So you have to be very, very familiar with these polyatomic ions so that you recognize them immediately. So notice this one down here is a little bit strange. There is no metal here. So we defined an ionic compound as a metal plus a nonmetal. So that's an incomplete definition. An ionic compound is a bond between 2 charged species. So it just so happens NH4 ammonium is a positively charged polyatomic ion. So a better definition for ionic compounds would be a cation plus an anion. So ammonium is the one of the only times you'll see a positive nonmetal that you'll have an ionic compound, so you should be aware of that. So let's go through these. Just name what I see. Barium sulfate. Don't change anything, nothing fancy, just name what you see. Calcium carbonate. Nothing fancy, just name what I see. Ammonium acetate. Okay, so you see that ionic compounds with polyatomic ions are very, very, very easy to name if you know your polyatomic ions, and if you don't, then this will be almost impossible to complete. Okay, so those are the first two groups of ionic compounds that we're going to name. So now let's look in opposite direction. Let's figure out how to go from the name to the formula. Okay, so I believe that's labeled as C in your notes. There are a couple of rules. The first rule is to find the charge of both the cation and the anion portion of the compounds. So to start off with, we're actually going to write that down so we can see it. But then eventually you'll stop doing that. The second rule is if the charges don't cancel, okay, you switch the absolute value of the charges and write them as subscripts. So if the charges cancel, we're good, we're done. But if they don't cancel, you flip the absolute value of the charges and write them as subscripts. So I know that's a lot of words. Let's kind of look at what this means. So we'll label this writing formulas. So we have, let's see in your notes, I think you have barium chloride. You have calcium carbonate. I think that's the only two you have listed there. Okay, so let's look at what's going on here. So the first step is to find the charges. Well, how in the world do I find the charges? You go to the periodic table and you use the charge pattern. So barium is an alkaline earth metal, so it's +2. Chlorine is a halogen, so it's -1. Ask ourselves, do they cancel? Does +2 cancel -1 equals 0? No, it doesn't. So I have to do rule 2. So between rules 1 and 2, you can go ahead and write in, you write the symbols. Okay, so the first good step is always to get the symbols down there. BaCl. Okay, that's good. We're on the right track. So I flip the charges and write them as subscripts. But I flip the absolute value of the charges, and you never write plus or minus down here. So barium had a 2. I flip that and goes to chlorine. Chloride had a -1. The absolute value of that is just 1, so I write that by barium. But you never write a 1, okay? So never use, we'll say, subscript of 1. If you do it, it's not the end of the world. It's just not the best way to write it, okay? So that's your final answer, barium chloride. So let's check and see if it's in fact neutral now. So barium has a +2 charge. I have one of those, so that's +2. Chlorine or chloride is -1, so I have 2 -1s. So 1 + 2 plus 2 -1s gives me an overall 0 charge, so I'm on the right track. Okay? So calcium carbonate, I look at the periodic table, calcium has a +2 charge. Carbonate, I know from memorizing the polyatomics, has a -2 charge. Okay? So go ahead and get the symbols down here. CaCO3. Ask yourself, does +2 and -2 cancel? Yeah, so we're done. CaCO3 is my final answer. Okay? If you were to flip it down and write Ca2, CO3, 2, then you have to go back and reduce them. Okay, so you always want to have the reduced form of the subscripts. But if it cancels, you're good. So you can go ahead and stop there. So let's look at one more. Let's look at, let me see what's in your notes. Hold on just one second. Okay, here we go. So let's look at magnesium iodide. Let's look at calcium nitrate. And let's look at potassium phosphide. Okay? So step 1, go ahead and figure out what the charges are. Magnesium's +2, ionine's -1. Next step, go ahead and get the symbols down there. Mg, I, just write them in. Take the absolute value, flip the charges, write them as subscript, so Mg, I, 2. You go back and check ourselves. We have 1 positive 2 and 2 negative 1s. So +2 -1 -1 gives me 0, so I'm good. So calcium is +2, nitrate's -1. Go and get the symbols down there, CaNO3. I flip the charges and write them. Here's our extra rule though. If a polyatomic ion needs a subscript, you have to put it in parentheses. Okay, so there's our correct answer. We have 1 positive 2 calcium and 2 negative 1 nitrates that cancel. If you don't have that parenthesis, what you're saying is you have 1 calcium, 1 nitrogen, and 6 oxygens. Okay, whereas really we have 1 calcium, 2 nitrogen, and 6 oxygens. So don't forget the parentheses if you have a subscript on your polyatomic ion there. So the last one, potassium phosphide. So potassium is +1, phosphide is -3. So we go and get the symbols down, Kp. Take the absolute value and I flip them. So I have K3P, I'll leave the 1 off. Let's go back and check myself. I have 3 + 1 charges, I have 1 - 3 charge. That cancels and gives me an overall charge of 0 there. Okay? So it's a good step when you get done with every one of these, go back and check yourself. Think about how many of the positive charges do I have, how many of the negative charges do I have, and make sure that they equal out to 0 there. Okay? So now we want to look at the transition metals. Okay? We know that one of the key features of transition metals is that they have a variable charge. Okay? So if I just tell you you have an iron atom, what's its charge? You can't tell me that. There's no way of knowing. Okay? But if it's in a compound, then you can tell me the charge. Okay? So let's look at a couple of ionic compounds that contain transition metals and see what the unknown charge, or see what effect it has on the naming. I apologize, I have a lot of words there. Let's look at a few. Let's look at FeO, Cu2O, FeCl2. Okay, so rather than listing out rules, there's FeCl3 in your notes, I apologize. Rather than listing out rules, I think it's easier to learn these by doing. Okay, so these are still binary ionic compounds, so nothing changes there. So let's go ahead and do what we already know first. So I have iron, I name the metal, change the nonmetal to IDE oxide. Okay, but now if it's a transition metal, okay, so if we'll say if variable charge with VC, if it's a transition metal, and there are a few exceptions that we'll discuss. So if variable charge, you must show charge and name using Roman numerals. So hopefully you know your Roman numerals: 1, 2, 3, 4, 5, and so on. Okay. So we have to figure out what this iron's charge is. So that's a little bit tricky, right? But we know the overall charge of this compound has to be 0. Okay, we know they all have overall charges of 0. And I can know oxygen's charge. So if oxygen's charge from the periodic table is -2, okay, what does iron's charge have to be to cancel out that -2 and get a 0? Yeah, it has to be a 2 there. Okay? So the correct name here is iron 2 oxide, because I know this iron has to cancel the charge of this oxygen and give a 0. And from the periodic table, I know that oxygen's charge is -2 there. So let's try another one. Let's do the easy part first. Do what I know. Copper oxide. Okay? So I know their charges have to equal 0. I know oxygen's charge is -2. So the total charge of these two coppers has to be +2. So if the total charge of the copper is positive 2, what does the charge of each copper atom have to be? Yeah, each copper has to be plus 1. Okay? So I have one copper plus another copper minus an oxygen with a negative 2 charge gives me a charge of 0 there. So notice you don't write in parentheses the overall charge for the metals, you write it the charge for a single metal, one of the single atoms. Let's look at the last one. I have iron something chloride. Okay. So chlorine has a negative 1 charge, but I have 3 chlorines. Okay. So I have a overall negative 3 charge. So something minus 3 has to equal 0. So whatever iron's charge is minus 3 has to give me 0. So hopefully you see that iron's charge has to be 3 there. Okay? So the only time you'll ever use these Roman numerals is in parentheses with a name. Okay? A couple of exceptions that we have for transition metals are zinc and silver. There are a couple of others, but for this class we'll only use these two. Zinc always has a plus 2 charge. Silver always has a plus 1 charge. You just have to know those. So if I have AgCl, that's silver chloride. It's not silver 1 chloride because I know silver's charge is plus 1. It doesn't have a variable charge, so it's just silver chloride. So zinc, ZnO, is just zinc oxide. Okay? It's not zinc 2 oxide because I know zinc's charge is plus 2. That's why I kind of stepped back. I didn't say if a transition metal, I said if it has a variable charge. So the variable charges are the transition metals that aren't zinc or silver there. Okay? So let's go in the opposite direction now. Let's go from a name with a variable charge to a formula with a variable charge. This is probably the easiest of all the things that we do. So we have iron 3. I don't know if I said this or not. I apologize if I didn't. How we read these. We read these as iron 2 oxide, copper 1 oxide, iron 3 chloride. So we'll make a note of that to make sure you say them correctly. So copper 2 chloride. If you write this, you're wrong. Okay? Only Roman numerals go in parentheses there. And the last one is lead. IV is what? It's 4 phosphide. Okay. So we have to think, well, what in the world does this Roman numeral change? What does it do? All the Roman numeral does is it tells you the charge of the metal. Okay. So now it's just a binary ionic compound, so nothing's different. So oxide is negative 2. I get that from the periodic table. I write my symbols. FeO. Do the charges cancel? No, they don't. So I take the absolute value and I flip them. So Fe2O3. And I'll look over here. The first step is to write the charges. I can look at the periodic table, see chloride's negative 1. Think, well, what is copper? Okay, copper, the Roman numeral tells me, it's plus 2. So I write the symbols, Cu, Cl. Do they cancel? No, they don't. Take the absolute value and flip them, Cu, Cl2. Okay, I do not have to write the 1 there, it's understood. The last one is lead phosphide. Write the charges in. Phosphide is negative 3. Lead, oh, sorry. I went ahead and abbreviated lead there. I should have written out lead. Yeah, so don't do like I did. It's incorrect if you mix symbols and words there. So you should write that out as lead 4 phosphide. Okay. So what's lead's charge? Lead's charge is plus 4. The plus 4 and minus 3 cancel. No, they don't. So I flip them. Pb3, P4. Okay. So that's my final answer there. So don't be scared by the Roman numerals. Okay. They don't change anything, they just tell you what the charge is. So let's list a couple of rules here, a couple of common mistakes. So don't use 1 as a subscript. Okay. Never use, we'll say, Roman numerals in a formula, only in names. Okay? Never use a plus or minus in a formula. Let's see if there's any other common mistakes I can think of. And then just keep in mind that silver and zinc have set charges. So let's go ahead and list out a few of these and try to name it. So I'm going to pause the video and list out some problems for us to try. Okay, so if you want to go ahead, you can pause the video and try these on your own, then come back and watch me talk through them, or you can just watch me talk through them the first time. Either way, it doesn't matter. So we'll do the first column first. I give you the names, or give you the formulas. I want you to write the names. Okay, so the first is a binary compound. Okay, is there an atom with a variable charge here? No. I can go to the periodic table and find magnesium's charge. I can find iodine's charge. So nothing weird is going on here. So I just name the metal, magnesium, change the nonmetal to IDE, iodide. Okay. Second one, same thing. I name the metal, change the ending to IDE for the nonmetal, but I'm not done. Iron has a variable charge, so I have to recognize the transition metals when I see them. So I have to go back and figure it out. Iodine has a -1 charge, but I have 2 of those. So what does iron's charge have to be to cancel out that -2 from the iodine? Yes, it has to be 2. Okay. So the next one I have a polyatomic ion. So I name the metal, name the polyatomic, I'm good to go. Another polyatomic, name the metal, name the polyatomic, but here I'm not good to go. Copper is a transition metal with a variable charge, so I have to determine what copper's charge is. I know nitrate's a -1, so I know something -1 has to equal 0. So in this case, I know copper is a +1 here, so copper 1 nitrate. Here I have a metal with a polyatomic ion, so I name the metal, silver, sulfate. Don't change anything here. Do I need to put the Roman numeral here? No, because silver does not have a variable charge. Silver is always +1, so I'm good to go here. Okay. So the first step when I'm writing the formulas from the names, I write the charge. Cesium's +1, oxygen's -2. I write the symbols, CS, O. Do they cancel? No, they don't, so I flip them. So CS2, O. Now I'm good to go. I can go back and check. +1 +1, -2 equals 0. I'm good to go. Barium phosphate. Barium's +2, phosphate's -3. Write the formulas. BaPO4. Do they cancel? No, they don't, so I flip it. Ba3, PO4, 2. I need to put the phosphate in parentheses, okay, because there are 2 phosphates there. So go back and double check. Does it cancel? -3 times 2 is -6. +2 times 3 is +6, so we're good to go. Copper phosphate. The Roman numeral tells me copper's +1, copper 1 phosphate. Phosphate is -3. So I write the symbols. Cu, PO4. Do they cancel? No, they don't, so I flip it. Cu3, PO4. Do I need to write the 1? No. So because there's only 1 phosphate, I don't need parentheses there. If you write it, it's not the end of the world, but it's standard convention not to. So the last one, ammonium oxide. There's not a metal here, but there is a positive ion and a negative ion, so it's still an ionic compound, so I'm good to go. Ammonium is +1, oxide is -2. I write the symbols. NH4, O. Do they cancel? No, they don't, so I flip the charges. NH4, 2, O. So I'm good to go now. They cancel that up to 0, okay? So that is how you name the compounds and write the formulas for pretty much all ionic compounds. So before we move on to the next set, which is covalent compounds, we're going to practice these for a while and get a good grasp on these. You want to make sure you have a good grasp on each type of compound before you start trying to name the next one so the rules don't all run together.